So we're going to wrap up with a couple more lessons about overviews of Java threads. This particular lesson focuses on key methods in a Java thread. And as you'll see, there's a whole bunch of methods. We're not going to talk about all of them, but we're going to talk about some of the ones that are the most important. So certain methods in the Java thread class are used in many concurrent Java programs. There's a couple methods that are always used, and we'll talk about some other ones that are very commonly used. One that is not that common but is important to understand is set daemon, and this marks the thread as a daemon. We'll talk about what a daemon thread is in an upcoming lesson. I think I briefly talked about this before, but if not, a daemon thread is a thread that will automatically terminate when all so-called user threads go away. And I'll talk about that in more detail later. So you can make a thread a daemon thread. Another thread that's absolutely needs to be used, otherwise you don't get a thread at all, is the start method. And the start method allocates thread resources and initiates the execution of the thread by calling the run hook method. The start method can only be called once per thread. You have to call it or else you don't get a thread, and you can only call it once. If you try to call it more than once, you get an exception. The next question is, what's the run method? It's a hook method where user code is supplied. A hook method just means a virtual method that's called back by a framework. So the thread framework, that's part of the Java class library, will automatically ensure that the run hook method is called back. That's where you put your business logic, your user-specific code. The inverse, if you will, of start is join. And what that does is that blocks the calling thread, whoever calls join on another thread, it'll block the calling thread waiting for that thread to finish, either normally or abnormally. And it's a very simple form of what's known as barrier synchronization. So barrier synchronization is this mechanism by which you can wait for something to finish and then you can do your next thing. There's another method which you don't use directly, but we use it internally to our implementation called sleep, and it causes the thread to sleep for the given amount of time in milliseconds. And we use that when we do gazing in our Palantiri manager because it needs to gaze for a certain amount of time. We make that kind of a random time between half a second and 4 seconds or whatever. A very interesting method is called current thread. This obtains the object for the current thread, and it's actually a static method. And this particular method can be called, and it'll always return the thread object for the current thread. And if you look carefully here, you can see that we have current thread is marked with an S, which means that it's a static method. Now, there's a series of methods that deal with interrupts. We're going to talk a lot more about interrupts later, so I will just do this very briefly now, but they're an important concept to understand in Java. And the interrupt method posts a so-called interrupt request to a thread. So you call interrupt on another thread. You're one thread, you're the main thread or whatnot, and you want to interrupt another thread, you can say thread, if you have the thread object, dot interrupt. And that tells the other thread, please shut yourself down when it's convenient for you. Those are what are called voluntary or cooperative cancellation or interrupts. Now, if you are a thread, you can check to see if you've been interrupted. And there's a couple of ways to do this. There's some really subtle stuff here. I won't spend a lot of time on it now. We'll talk about it in much more detail later. There's two methods. One is called is interrupted, and the other is called interrupted. The is interrupted returns true if the thread has received an interrupt request from another thread. And it tests it, but it doesn't affect the interrupt status flag. It just says, has it been interrupted or not? Yes or no. So it returns Boolean. There's another method called interrupted, and this method is a static method, and it tests to see whether the current thread has been interrupted. And it's a bit more subtle because it clears the interrupted status flag the first time it's called. So you can find out if something's been interrupted and clear the flag. Now, again, you may or may not make heads or tails about what I just discussed. Don't worry about that. I will not quiz you on these things till we cover them in more detail. But these are very important methods that you can use to voluntarily get threads to shut themselves down when they're no longer wanted. What would be an example of why you might want to do this? Well, if you're able to run the emulator on Android for the Palantiri simulator app, you'll see that there's a little floating action button in there, And when you start the app, looks like a little start icon. You push start, it starts to run, and then it has a little X in it from that point onwards. If you click the X, that will cause the app to terminate. And since the app has a bunch of threads running around in it, we use the interrupted mechanism to cause those threads to shut down. Another method, compare methods really, set priority, get priority. They set and get the priority of the thread respectively. And this is important. If you have multiple threads that are capable of being run, then the semantics of Java are that the thread with the highest priority should be the one to be running if there's a choice between higher and lower priorities. If they're all the same priority, then the scheduler can just decide based on whatever it deems its scheduling policy to be. But if you have different priorities, then the higher priority thread gets a chance to run. And the way it works in Java is that higher values of priority result in higher priority threads. Some systems, lower values mean higher priority. In this Java context, higher values mean higher priority, which is a bit more intuitive in some ways. So that's the end of the Cliff Notes summary of key methods in a Java thread. Some of these things I do expect you to know. For assignment 1, in particular, you should know how to do start. You should know how to fill in run. And you should know how to basically join. Now, the fill in run part is actually kind of done for you in the simple being runnable class. And it's actually a template method, the template method pattern in the Gang of 4 book, if you're familiar with that, where the run hook method basically ends up calling something that ends up calling acquire, palantir, and gaze. So you don't actually have to do the run method. You just have to set things up so the run method is called. But the key things you really need to know are starting a thread and joining a thread. And remember, you never call run on a thread. That's what is done when you start it.